Hi students, I welcome you all for the sessions. Today we'll be start a new chapter, that is linear inequalities. So we'll understand what is the meaning of linear and inequalities before going to discuss about content. So linear means what? So the equations having only x term, right? This x plus 1, and if we write 2x plus 1 is equal to 0, 2x plus 1 is equal to 0. So these type of equations will be called as linear equations, right? Which contains only x term, right? Only one x, right? These only 1 degree, right? 1 degree of x. These called linear equations. And if we write, so if we write the equation is containing of x square plus 1 is equal to 0, or x 2x square plus x plus 1 is equal to 0, these type of equations, and the having 2 degree, right, having more than 1 degrees, are x cube plus 1 is equal to 0, right? The degrees are more than 1, so such type of equations are called as non-linear equations, right? Non-linear equations. So here in this chapter only we are interested about linear equations, right? Linear equations means this type of equations, and inequalities means what? So you know about, and suppose I am writing here 8. So 8 6, among these two, which is greater number? 8 is greater number, right? So this symbol is that this is symbol, right? This symbol will be used for the greater symbol, right? This is 8 is greater than 6, and less than symbol is this one, right? Suppose I'm writing 4, 4 is less than 5, right? 4 is less than 5, and if I write here and less than or equal to, so less than, this is the symbol for less than or equal to. Less than or equal to means both here, this is less symbol or equal, right? It is whether less than or equal to 5. Suppose I am writing here, so this is 3, 3 3, this is equal, right? So 3 is equal, so 3 is either here x number, suppose I am writing x number here, so x is either less than 3 or equal to 3, right? Suppose I am put the value of x is equal to 1, so here x is less than 3. Suppose and x is equal to 2, 2 is less than 3, and x is equal to 3 I am put, then it will be equal, right? X is equal to equal, right? So such symbols, such these symbols are called greater than, less than, and less than or equal to, and greater than or equal to. These symbols are called as inequalities, right? These symbols are called as inequalities. Inequalities. Inequalities, right? So now we will be going to discuss on this inequalities. The topic is that inequalities. 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 So I will give example here, so then you will understand. Suppose an x person, right? X person, so you say any name, right? X person, Ravi. Okay, the name of the person is Ravi. So he goes to market with the 200 rupees. He goes to the market with 200 rupees. He is having 200 rupees. He goes to the market with the 200 rupees, and he he purchasing up 1 kg of pocket. So he is purchasing 1 kg of pocket. That is the cost of rice is the 1 kg of rice pocket is 30 rupees, right? 30 rupees. And so the and the number of pockets will be x, right? So you say this number of pockets, right? So number of rice pocket will be x, right? Then the total cost of the price is, so 30 for one pocket is 30 rupees, and the number of pocket is x, therefore it is 30x, right? Total cost price of total cost price is 30 into x, right? So this 30 into x, so within the 200 rupees, so within the, as I mentioned here, he's having 200 rupees. Within 200 rupees he has to purchase the number of pockets, means what? 30x is less than 200, right? Within the 200 rupees, and cost of price one price pocket is 30 rupees, and number of pockets will be x. Then within the 200 rupees he has to purchase, okay. So in the number of the equation is 30x less than 200, right? This is an one type of equations, okay. And here the second example I will going to give here. Second example, suppose say Reshma, okay, Reshma has 120 rupees, okay. Reshma has 120 rupees in his pocket, right? And the cost of he has to he wants to purchase a register book, and along with that pen, right? He has to purchase he wants to purchase the register and pen, okay. And the cost of register is that, so the cost of register is that 40 rupees, right? The cost of register is 40 rupees, and the cost of pen is 20 rupees. So pen is 20 rupees. So uh, we don't know what is the how many number of registers she want, and how number of pen she want, right? Suppose giving x is the number of registers, and y is the number of pen, and the total amount spent is that total amount on this purchase, total amount is so register is 40 rupees, and number of register is 40x, and 20 rupees for pen, and number of pen is y. So the equation is 40x plus 20y, and she has to purchase uh, within with less than 120 rupees or equal to 120 rupees, she has to purchase, okay. She has to purchase uh, within 120 or equal to 120 rupees she has to purchase. This is an equation for this statement, right? So we can by the statement we can write mathematically, right? So what is the meaning of this statement? So Reshma has to purchase the register and pen. So number of the register cost is 40 rupees, and cost of the pen is 20 rupees, and number of the register is x, and number of the pen is y, and she has to purchase within the 20 rupees pen and register also. But how many numbers we don't know, right? This is an equation we'll be giving equation number 2. So here in equation 2, if we observe, so equation number 2 contains two statements. I am writing here 40 x plus 20y. So either this is less than 120, or either it will be uh, equal to 120, right? So this is having two statements, right? So either less than 120 or equal to 120, and these statement 3 is not an equations. If we observe, if we use in equations here 3 and 4, so statement 3 is not an equations, okay. This is not an equations, right? So equations usually equal terms will be there, right? X plus y equal to equal term, right? So like this type of expressions will be called as a equations, right? Equation the fourth is an expression fourth is an equation, right? While the statement, this is an statement 4 is an equations, okay. So now we can able to define what is the statement of inequalities. So I will write here definition. So definition, two real numbers. So two real numbers, either it is positive or negative, right? Two real numbers are, we can say, as two algebraic expressions, whether it may be number or uh, expressions like this type. This is an expressions, and numbers are minus 2 3 minus 3 1 2 3. These are the numbers are expressions. Two real numbers are algebraic expressions related by the symbol related by the symbol. The expressions, the real numbers are expressions are related by the symbol greater than or less than or greater than or equal to less than or equal to form an equality, form and equal inequalities, right? Form an inequality. The expressions, So what is the definitions? Any two numbers, right? Any two real numbers. Two real numbers means x and y, you say. Any two real numbers are equations, expressions x plus y. Yeah, real numbers are expressions having the relations with the greater than or equal to, less than or equal to, are greater than equal to, less than equal to, less than or greater than. These symbols are called as inequalities, right? These are called as inequalities. Suppose I will give you example here. So I will give example here. So these numbers, right? So 3 is less than 5. Okay, so 7 is greater than 5. So such type of expressions are called as numerical inequalities. Numerical inequalities. Such type of expressions are called numerical inequalities. And when x is less than 5, y is greater than 2, and x is greater than or equal to 3, and y is less than or equal to 4. This type of equations or expressions are called as literal inequalities. Literal inequalities. So means what? Here x is whatever, x is whatever it may be. Whatever it means, it is one, either it may be 1 2 3 4, right? 1 2 3 4. And here y will be y will be 1 minus 1, whatever it may be, based on here real number or natural numbers. So these are numbers are here, values are more. Such type of expressions are called literal equalities. And here, so only one values we will be having, so 3 is less than 5. These are called as the numerical inequalities. Now come to the some examples. So by the examples, we'll understanding of linear and non-linear inequalities. So I will give example here, ax plus b. So this is, if you observe, this is linear expressions, right? So here only one degree of x is there, only one degree of x is there, right? No x square is there, right? So this is linear. So I will give an equation here. So here equation 1, okay, and I will write here ax plus b is greater than 0, equation number 2. And I will write here ax plus b less than or equal to 0, this is equation number 3. And I will write here ax plus b greater than or equal to 0, this is equation number 4. And I will write here, so only one variable we are having in this linear equations. And now I am writing two variables. This is ax plus by, this is less than c, right? Here less than c, so this c is a constant, right? This is an equation 5. And ax plus by, so two variables are there, x and y. This is also linear equations, and it is greater than c, so equation number 6. And here, so I will write ax plus by, it is less than or equal to c, equation number 7. And the ax plus by greater than or equal to c, equation number 8. And now I will write here, uh, so the other expressions, non-linear, right? Non-linear, x square is there. So other than 1 degree, so are non-linear equations, x square plus bx plus c. So it is uh, less than or equal to 0, this is equation number 9. And ax square plus bx plus c less than or equal to 0, this is equation number 10. And ax square plus bx plus c greater than 0. So these are non-linear type of equations, okay, only non-linear type. And these equations are called linear with two variables, linear with two variables, with two variables. And here, so linear with only one variable, right? So these are the inequalities. Linear one variable with one variable, inequalities, right? So in your syllabus we are only interested about linear, so this is not in your syllabus, okay? Will be we are only interesting about linear type of inequalities. And now, so here, and these symbols, right, when we are having, so here greater than, less than, and less than, greater than, these are called as strict inequalities. Only one condition is there. These are strict inequalities. And when we are having two variables here, here it is less than or equal, greater than or equal, these are called as slack inequalities. Slack inequalities. Okay, you understood what is the only one condition is there, either it is greater than, less than. So such inequality is called as strict inequalities, and two conditions, more than one conditions, will be called as slack inequalities, right? So now we come to the some next content, that is algebraic solutions of algebraic algebraic solutions of linear inequalities in one variable and their graphical representation. Okay, in one variables means only having one variable. Suppose we have been discussed in last expressions. First example, 30x is less than 200, right? So Ravi goes to market 200 rupees, and the price of 1 kg pocket is 30 rupees. That is example we discussed in first, right? Example one. So that equations I am writing here. So here when we are putting the value of here x is equal to 1, it will be 30. So 30 is less than 200. This statement is true, right? This statement is true. And when we put x is equal to 2, 30 into 2 is the 60. 60 is less than 200. This is also true, right? 60 is less than 200, and x is equal to 3, and 33 is 90, and it is less than 200. This is also true. When we put the value of x is equal to 4, so 3 4 is 12, it is 120, and it is also less than 200. It is also true. And when x is equal to 5, 35 is 150. This is also true, and this statement is true here. And when we put x is equal to 6, then we'll be having 180. It is also less than 200. This statement is true. When x is equal to 7, so 3 7 is 21. 210 is not less than, so 210 it is not less than is 200, then it is false. The statement is false here. Okay, the statement is false. So therefore the values are here. So values are 1 2 3 4 5 and up to 6 is there. So it is a set of so we can say 0 also you can put, right? 0. So when we put the value 0 here, so 0 is less than 200, right? 0 is less than 200. And these are the solutions of these equations, right? The solutions of the solutions of 30x less than 200. So this is the solution of set of this equation, right? So we called as is a solution set, right? It is called as a solution set of the this equation, right? So now when we can represent an equations, right? So I will give an example here, some rules. So rules of inequalities. So when we can say 3 is greater than 2, right? 3 is greater than 2. It is true. And this I can maybe write as if I am giving minus here, so this is also, this side is also minus. This and this statement is true, right? So both side I am giving negative. So both side I am giving negative. If this is also one rule, rule number one. And if we take here minus 8 is less than minus 7, right? So minus 8 is less than minus 7. Okay, the greater negative numbers are less than the smaller numbers, right? So here I am writing, so minus 1, minus 2. So we seems that 2 is greater than 1, but in negative numbers, so 2 is less than 1, right? The greater negative number, so the greater negative numbers are less than the smaller negative numbers in negative case, right? So this maybe I can write as so minus 8 is less than so I will be multiplying minus 8 with minus 2 in this side. Therefore in the right side also I will multiply minus 7 into minus 2. So the meaning is same here. 8 2 is minus into minus is 16, okay, and 7 2 is 4. 16 is 16 is 16 is okay, we can write as so this is 16 we can write as so 16 is greater than 14 here, right? We can write so while okay, so this we can be convert. Just give an example here. So if okay, this is 8 is less than this 8 is less than minus 7, this is true statement. So this one I can convert this one I will be converting by multiplying minus 2, so it will be become a greater than or greater than the so this number 8 to the negative is positive 6. I can convert the less than to the greater the symbol. This is an also one type of rule. We just have to remember these things. I will be give examples, then you will be understanding the how to resolve the inequalities. Example number one. So solve 30x is less than 200. So here the x is the condition is that x is a natural number, so x is a natural number, and the second condition is that x is an integer, right? X is an integer. So we understand that here what is the natural numbers. So the positive numbers other than 0 are called as the natural numbers. 1 2 3 4 5 positive other than 0 numbers are called as natural numbers. Integers means both it will be negative and positive. 0 and positive numbers are called integers. This one you know from the chapter 1, right? So if I put the value of here, so if I put the value of here, so here this one 30x divided less than 200, I will solve these equations. This we can solve this equation like this. So this I will be make this was x as a single term, right? So what I do here, this in these equations I will to make a single x here, just I will be divided by 30 here. Okay, I will be divide both side by 30. Why because why I am dividing by 30? Because I just want to make x term as a single. Therefore I am dividing by 30 on both sides. 30 will be get cancelled, so x only will be having, and 0 will be get cancelled, and will be having 20 by 3, right? X is less than 20 by 3, right? So like this also we can solve, or we can solve 30x less than 200. Just we need to take 30. I am taking this side, it will be going to divide, right? So if we take this on the this side means it will be bottom over, right? This right this. So if we take 30 this side, it will be going to divide, right? X is 200 divided by 30. Okay, so the meaning of this and this is both are same. Okay, so here we got x is less than 20 by 3. So when we put the for the first case natural numbers are 1 2 3 5. So first case I will put here x is equal to 1 2 3 4. Okay, 1 2 3 4 5 so on. So here when we put x is equal to 1, so it is 20 by 3. Oh, right, 20 by 3 we are having 6 3 6 is 18 2 point, so point 6, okay, 6.66 will become value. So 1 is less than 6.6, it is true. 2 is less than 6.6, or we can write 20 by 3, right? 20 by 3, this is true. And 3 is less than 20 by 3, this is true, right? And 4 is less than 20 by 3, this is true. 5 is less than 20 by 3, this is true. But 6 is also 6 is less than 20 by 3, this is true. 7 is not less than 20 by 3. So values are here 1, 2, 3. The solution of set is the solution of set of inequalities here. So you just write here. So the solution of a set of inequality is here 1, 2, 3, 4, 5, 6. Okay, now we come to the second statement. The second statement is x is an integer, right? X is an integer means both positive and negative numbers I have to put. So here, so if we put here x is less than 20 by 3, the statement, right? So if we put negative numbers, so all negative numbers will be satisfied, right? All negative numbers will be satisfied. All negative numbers here, all negative numbers. Suppose I will write here -1, -2, minus 3, all these numbers continuous means triple dot I will put here. So these are less than 20 by 3. So just I will write here. So and positive numbers are, so positive numbers, solution of this set is that, so all negative numbers means continuously, this triple dot means continuously. So -3, -2, -1s all are satisfied by this equation less than 20. And positive numbers are, we know that positive numbers 0, 1, so integer contains 0, right? So 0, 1, 2, 3, 4, 5 up to 6 will come, right? So this is the solution of set of for these conditions. Okay, this is the solution of set of the set of inequalities, right? For the x is an integer. So for natural number, this is the solution of set. Okay, so we depend on the x is a real number or integer. So we need to solve this, solve the inequalities, right? So now we come to the next example. Okay, we can take the next example 2. So we need to solve this inequalities 4x plus 3 less than 6x plus 7. So you just do here. So you just less than symbol is there, just here. So 4 3, you 3 take this side, and 3 take this side. So 3 take this side. So when then we will be having 4x less than 6x 7 minus 3, right? When we are taking 3 this side, it will be minus. When we are taking okay, so this side means, okay, suppose here, so 20x is less than 200. So when we are taking this side means it will be only one term is there. So this will be divided, right? X is equal to less than 200 by 20. When we are taking this side means it will be plus will be get minus, right? Plus will be get minus, then it is 4x less than 6x plus 4, right? So now this now if we 6x 6x I am taking this side, then it is 4x minus 3x, 4x minus 6x less than 4, and it will be 2x less than 4. And so x minus x is 4 by 2, right? It will be divide, then it is 2, right? Minus x is less than 2, right? If we, so okay, if we convert this one, okay, if we convert this one in a greater symbol, so if this one we can write as a, this one we can write as a, x will come to this side means it will be greater than -2, right? If we take the minus this side, so then it is greater symbol will come, x is greater than -2, x is greater than -2. And here, what is the solution of this equation? So x is greater than -2 means what? Here solution is that, so x values, so x values means what? uh, all real numbers. The meaning of this is that all real numbers, real numbers greater than -2 are the solution of the given inequalities. Means the solution of the set is here. The solution of this set is here. So greater than the -2, all numbers greater than the -2. -2 means it is continuously infinity, right? Infinity number. So then it is right, continuously infinity number, then solution of the set is -2 infinity, right? So next we take an example of example number 4. Okay, we take the example number 4. Okay, so here 5x 5 minus 2x divided by 3, and it is less than or equal to x by 6 minus 5. Okay, so this what I do here. So here I will take LCM here first. So 5 minus 2x divided by 3. So here LCM what 6 1 okay, LCM is 6 here, and this is x, and this is 5 1 into 6 is 5 6 is 30. This is x minus 30. So now these 3 I will take this side, and this 6 take I will this side. So therefore it is 6 into 5 minus 2x, and this is 3 into x minus 30, right? X minus 30, this is symbol is less than or equal to, right? And 6 5 is 30, 6 2 is 12, 12x, and this is less than or equal to 3x, and this is minus 90, right? So when we are solving this one, so when we are solving this one, okay, so when we are solving this one, so we'll be having, so 3x take this side, so minus 12x minus 3x, and 30 take this side, this will be less than or equal to minus 120 we'll be having. Okay, this is 12x, right? Then we'll be having minus 15x less than or equal to minus 120, right? So these we can write, negative signs will be get cancelled, and will be x is less than or equal to uh, less than or equal to. So when this negative signs, okay, when we are converting this one, okay, when we are converting negative, so this negative I can write as a positive, right? If negative I can write a positive, then it will be greater than or equal, right? So when I am writing this negative as a positive, then it is greater than or equal to symbol will come. Then x is greater than or equal to 120 divided by 15. 5 3 5s are 15, 3 4s is 12, and then it is 40 by 5, 5 ones are 5 eights are. Then the x is greater than or equal to 8. Okay, x is greater than, then solution of this all real numbers greater than or equal to 8 are the solution of this given inequalities. Means what? So here x is belongs to the belongs to 8 to the infinity, right? X is greater than or equal to 8, 8. So x is greater than or equal to 8 are the solution of the given set. Okay, so now, so greater than 8 means greater than 8 means which are infinity. 8 9 10 which are continuously infinity. Therefore 8 infinity are the solution for this given solution, given inequalities, right? Now when we are writing here, so we'll take, so another example. Okay, we'll take another example here, so then we'll be understanding. Okay, okay, so we'll take example number 5. So here, so 3x minus 4 divided by 2 is greater than or equal to x plus 1 divided by 4 minus 1, right? So this one we have to take this side LCM first. Okay, 3x minus 4 divided by 2, then it is x plus 1 minus 4 divided by 4, and here 4 I will take this side, then it is 4 into 3x minus 4, and it is 2 I will take this side, then it is 2 into x plus 1 minus 4, right? Then it is a 4 3 is 12x, 4 4 is 16, 2x plus 2, 2 4 is 8. Then we'll be having here, so this is greater than, sorry, this is greater than or equal to, greater than or equal to, and this 12 2x I'm taking this side, then 12x minus 2x, and this is greater than or equal to, and this is minus 6, 2 minus 8 is minus 6, minus 6, this plus 16 I will take this side, minus will be get plus 16 in this side, then it is 10x greater than or equal to, then 10 we'll be having. So the solution for this is x is greater than or equal to 1, right? X is greater than or equal to 1 is the solution for this inequalities. Okay, so in next class we'll be solving exercise number 5.1 based on this concept, right? Thank you for watching the video. Please subscribe the channel, hit the bell icon for the notifications. Please do share the video with your friends. Thank you for watching the video. Okay.